Hello everyone, we are going to learn about Quaternion Group Q8. Let us consider the set Q8 is equal to plus minus 1 plus minus I plus minus j plus minus k. Define product on Q8 by usual multiplication together with I square is equal to j square is equal to k square is equal to minus 1. Ij is equal to minus ji is equal to k, jk is equal to minus kj is equal to I, ki is equal to minus ik is equal to j. This is the composition table. From the composition table, we see that Q8 is closed with respect to the multiplication. Associativity also holds. The element 1 is the identity, because 1 into I is equal to I into 1 is equal to 1 into I is equal to I and I into 1 is equal to I. Similarly, 1 into j is equal to j into 1 is equal to j, etc. Every element has its inverse in Q8, that is I inverse is equal to minus I, j inverse is equal to minus j, k inverse is equal to minus k, minus I inverse is equal to I, minus j inverse is equal to j, minus k inverse is equal to k, minus 1 inverse is equal to 1 and 1 inverse 1 is equal to 1. We can see I into minus I is equal to minus I square is equal to 1. So, minus I is inverse of I and I is inverse of minus I. Similarly, j into minus j is equal to minus j square is equal to 1. So, j and minus j are inverses of each other. Here, ji is equal to minus ij is equal to minus k. So, Q8 is not abelian. Thus, Q8 is a finite non-abelian group of order 8. If set G consists of the 8 matrices of 2 by 2 order 1 0 0 1 minus 1 0 0 minus 1 I 0 0 minus I minus I 0 0 I 0 1 minus 1 0 0 minus 1 1 0 0 I 0 0 minus I 0, where I is equal to square root of minus 1, then G forms a non-abelian group under matrix multiplication. Let I is equal to 1 0 0 1, A is equal to minus I 0 0 minus I, B is equal to 0, 1, minus 1, 0. C is equal to 0, I 0. Then AB is equal to minus I 0, 0, minus I into 0, 1, minus 1, 0. This is equal to 0, I 0 is equal to C. Here I acts as an identity element or identity matrix. Similarly, B into A is equal to, this is 0 into 1, 0, 1, minus 1, 0, I 0, 0, minus I is equal to 0, minus I 0, which is equal to minus of C. Therefore, AB is equal to minus of BA is equal to C. Also, A square is equal to A into A. This is equal to I 0, 0, minus I into I 0, 0, minus I. This is equal to I square 0, 0, I square is equal to minus 1, 0, 0, minus 1. This is equal to minus I. Similarly, B square is equal to C square is equal to I. Thus, in the set G, A square is equal to B square is equal to C square is equal to this is minus. Similarly, B square is equal to C square is equal to minus I. Thus, in the set G, A square is equal to B square is equal to C square is equal to minus I. AB is equal to minus of BA is equal to C, BC is equal to minus of CB is equal to A, AC is equal to minus of CA is equal to B. Therefore, G satisfies all the properties of Quaternion group. Since AB is equal to BA, which is not equal to BA, so G is not abelian. Thus G is a non-abelian finite group of order 8.